Hi guys and welcome. Finally, grade 12s, it's your turn. Mindset, Learn Extra Live Physics. Last week we covered photoelectric effect with Phil. Tonight our topic is organic molecules, and next week our topic will be properties of organic molecules. The show tonight will start off with the lesson on organic molecules, and then after a break we'll work through an example or two. Phil, want to chat to us about what we're talking about?
Absolutely. As you can see, I'm passionate about chemistry. Tonight we're going to be talking about some organic chemistry. We're going to be talking about our friend carbon over here. We're going to be talking about carbon, which is element number 6. And we're going to be taking a look to see what sort of molecules that forms and how to answer questions about that. There's a challenge coming up. Make sure that you've got a pen and paper ready.
Yes, guys, and I've actually got that ready to post on the page, so you guys can download it onto your cell phone, share around with your friends, and, you know, really start learning more and learning extra. Lastly, guys, I just want to let you know we're going to be tackling your questions in the last section, the last 10 minutes. So please make sure that your questions do actually have to do with what we're talking about. It'll make it go so much faster and make Phil's job much easier. Right, Phil?
Absolutely.
Guys, there are many ways to get hold of us. Facebook.com/LearnExtra. Chat to me on Twitter @LearnExtra. We'll be taking our questions in the last 15 minutes of the break, so don't forget to get them in. Okay, so after the break, we'll be back with Phil. Hi Mindsetters, and welcome back, grade 12s. I know that you're super amped for this lesson and you're all sitting there on the edges of your seats waiting to learn more and learn extra. So I want to give a big shout out to Liberty. You guys rock, you guys make everything possible, and we love you lots. I think what we're going to do now is we're going to get straight back to Phil and we're going to get on with the show. Remember, keep sending those questions. Phil, take it away.
Thank you so much, Indy. What we're talking about this evening is the chemistry of carbon. That means we're talking about organic molecules. The really fantastic thing about this is whether or not you're writing our national exams or whether or not you're writing IEB exams, this is a big chunk of your chemistry exam. And the great news is, even if you weren't great at chemistry in grades 10 and 11, organic chemistry is very often a ray of hope, because organic chemistry is very different. It's very graphic, it's very visual, it's nice and easy to follow. So hopefully what we're going to do tonight is teach some of the people that haven't done this yet in school. We're going to teach them a little bit about organic chemistry, and it's going to be some revision for those of you that have done it. One of the things that I've done for you is I've prepared a really nice challenge question, and I want you guys to discuss this on the Facebook page because we're going to post it there, and I want you to try and discuss and try and debate what's going on inside this. Tonight we're going to be focusing on organic molecules and the naming of organic molecules. I'm going to try to keep it simple for those folks that haven't done it yet. We're going to hopefully try and move on to the more complex stuff, and I'm going to guide you through step by step, and we'll see how that goes. So why are we talking about carbon? Well, the main reason is that carbon is amazing. Over 90% of the compounds which we find in nature are made up of carbon. That means that we're getting close on 31 million carbon compounds, and they're growing every day. You can use carbon to build just about anything, including people, human beings. Life is carbon-based. Now, the reason that carbon is so versatile is because it can make 4 bonds to other atoms and itself. That allows it to do all sorts of amazing things. Carbon is the building block of life, and this is why we call it organic chemistry. Organic usually deals with the chemistry of life, and this is exactly what we're dealing with today. What we're going to do is we're going to post that challenge question. If you want to, write it down off the screen, or if you want to go to our Facebook page @LearnExtra, join us, participate and discuss it, and then we'll see where to go from there. I'm going to put it up on here, I'm going to discuss the various options, then I'll come back to it in the second part of our show and answer it. See if you can get the correct answer. It's a multiple choice. Questions A through to E are the correct answers, and there it is. I've got a molecule here, I've got a couple of carbons joined in a very interesting fashion. I've got a chlorine atom off to the side, please don't confuse that. That is Cl, so this is a chlorine atom. I've got a few carbons, a couple of hydrogens, an oxygen or two, and I've got to name this thing. Now this thing is an absolute beast of a question. Okay, it actually looks more complicated than it really is. So what you can see here is our structure. I can count at least 4 carbons, and I've got 1 carbon off to the side, off to the top, a chlorine off to the right, a few hydrogens, as I mentioned, those oxygens off to the side, and I've got a few options. Now, how you actually mention these, how you actually name these is actually quite difficult. There's a lot to swallow here, and these names are very long and complicated. I'm going to read them out for you at home if you're copying them down. The first one, my option A, is 1-chloro, 1-methyl propanoic acid. That's my option A. So I'm saying 1-chloro, 1-methyl propanoic acid. Option B is 3-chloro-butanoic acid. Option C is 1-methyl, 1-chloro-propanoic acid. Option D, pretty sure you can read it. It's almost like option B, except I'm saying 2-chlorobutanoic acid. And option E is 1-chloro, 1-methyl propanol. Now that looks a little bit weird. Now you can actually find out what's going on there. That's a reference to a ketone and an alcohol, but that's giving away a lot already. So get into these options, take a look at them, and see which one you choose. Write them all down and try and figure out which ones are wrong, which ones are right. So option A, B, C, D, or E. And all you have to do is get on that Facebook page, post your answers, and try and discuss who's right, who's wrong, and why you think you're right. Because you can learn a hell of a lot from these other people at home that are sitting on their computers and they're discussing the answers in front of them. I've got a lot to think about here, a lot of complicated words. Let's try to figure out how I actually came to these complicated names. Let's get into the steps. One of the things that you'll quickly learn is that organic chemistry is all about the method. It's all about the steps. Now, some very clever guys came up with a centralized system for naming all 31 million of those organic compounds. What they actually managed to do was to figure out that there is a centralized system, and I'm going to teach that system to you today. I'm not going to bother too much about the individual details of who these guys were, but we can benefit greatly from taking a look at the steps which they've designed. Now, I'm sure that you've noticed the thing which stands out the most is that carbon likes to make these chains. I'm going to look, first of all, for the longest carbon chain. One of the things that is going to do is it's going to decide the first part of the name. Now, the longest carbon chain, it can be quite a tricky thing. I'm going to be very, very careful about explaining what is the longest carbon chain and where can people slip up. Well, wherever got to go from there. One of the things that I'll notice is that I can bond carbon together in a different way. How is the carbon bonded together? Well, I've got a chain of carbons. I can bond them together in any number of ways. What I'll find is that I can use single, double, or triple bonds. If you've done this section, this should be very familiar to you. I count my longest carbon chain, I see how they're bonded together. Now that's not all. Sometimes you've got a little bit something extra on the side of your organic molecule. What if it's not all just carbon and hydrogen? What if it's not just a hydrocarbon? Sometimes I've got to go that one step extra, and I've got to find out if there are any functional groups and if I have to number my molecule. So step one, find the longest carbon chain. It's always going to go this way, and sometimes that's very tricky. I find out how the carbon is bonded. Then I'm going to find out if there's any extra little bits and pieces which are going to make my organic molecule very special. Now, these three steps are going to enable me to name 31 million compounds. Now, it's absolutely amazing that if I go through these steps, I can name so many compounds. I'm going to show you the bits and pieces, and we're going to try to figure this out together. I'm going to show you the first 8 carbon chains. In other words, carbon chains all the way up to 8 carbons. You can go further if you like, but all they need is the first 8, and then we'll go from there. So let's get into these steps. If I count the longest carbon chain, what does that actually mean? Well, this means that I find something called a prefix. Well, I'm going to highlight this word because not a lot of people actually understand the word prefix. Prefix is a part which goes on the front of a word. So if I find a prefix, that means that it goes right at the beginning of my word. So here's the steps. To find my prefix, I count the longest continuous chain. I can't emphasize that enough. It's got to be the longest possible chain, and it's got to be the continuous chain. I can't have any other atoms involved inside there. It's got to be carbon, carbon, carbon all the way. Now here's the trick, which you might not be following in class. Now this is one of the best tricks that examiners like to do. They say even around corners. Now remember that chains can bend in the middle. That means that I've got to count the carbons. Even when I get to the end, I've got to keep on counting and go downwards. These molecules are very tricky. I can bend them, I can twist them, they can make all sorts of amazing shapes. So when I'm counting my carbons, remember to go right around the corners once we're doing that. then I select the prefix. Now, what I've asked Indy to do is actually to post up the prefixes. Now, it's very, very difficult to actually write down this list because I don't want you sitting there scribbling at home. I want you to listen, I want you to watch, I want you to absorb. So, how do I select this prefix? Well, if you can count, you can select a prefix. There's a little bit of memorizing going on here, but once we've selected our prefix, we can go from there. So, I'm going to put up a list of these prefixes. You might recognize them. So, I've got my number of carbon atoms inside my longest chain from 1 through to 8. And I'm going to run through these prefixes because sometimes they're a little bit of a mouthful and I'm not actually sure what they mean. So if I've got 1 carbon, that means that I've got a beginning of my word that says meth. If I've got 2 carbons in my longest chain, eth, 3 carbons, prop, 4 carbons, bute. Now that's quite a confusing one because there's no E, but I am going to pronounce this as bute. 5, this one should start to make sense. If you remember from maths, from 5 onwards up to 8, these actually sound very much like the shapes, and that's going to save you a little bit of time. Anything which I can do to help you save time in chemistry, I'm going to let you know, and this is one of them. From 5 all the way up to 8, this is the same as the shapes in maths. If I've got a 5-sided shape, remember that it's a pentagon. So 5 is pent. 6 is hex, as in a hexagon. 7, hept, 8, and oct. And one of the ways that you can remember oct is an octopus, or an octagon. So if I've got 8 carbons, oct. 7 hept, 6 hex, 5 pent. Now, one of the ways that I actually tell my learners at home to remember these first few is rather than going meth, eth, prop, bute, it's very difficult to remember these 4 prefixes because they're not real words, and I can't remember things which are not real. One of the nicest ways that I can do is my brain is very good at remembering letters all together. So if you just take the first few letters of these, you can come up with some creative rhymes. I'm going to leave you to your own, but it's very, very easy if we actually summarize these. All you do is you get into your exam and you write MEPB, because a lot of people get confused between meth, eth, prop, and bute. So MEPB is the first 4 carbons, or the arrangement of 1 carbon, 2 carbon, 3 carbon, and 4. You can actually just write these out, and that'll help you remember when you get inside your exam. So meth, eth, prop, bute, MEPB is one of the quickest ways that you can do this. It almost rhymes, and it's a very, very easy thing to get used to. 1 carbon is meth, 2 carbon eth, 3 carbon prop, and then 4 carbons bute. Okay, now that I've counted my longest carbon chain, where do I go from here? We're going to get stuck into a few examples in a moment, once I actually show you how to select the end of the word. So I've selected the first half, now I'm going to move on to the second half. So either I've got a meth, eth, prop, bute, whatever I've got as my number of carbon, I've got to find out how they are bonded. Well, there's a couple of options here. Either the carbon is stuck to itself using a single bond, so that would be a carbon with a single covalent bond between the two, or a double or a triple bond. This will actually decide what the suffix of the name is. So single, double, or triple bonds. Those are the important things to realize that I've got to use. So single bonds, double bonds, and triple bonds are actually going to change our suffix, or the end of the word. I hope everyone's clear on that. So now that we've selected a beginning, we've selected an end, we can start to actually build on our molecule. Now, a lot of people are actually saying, what does a single, double, and triple bond actually look like? And here they are. You can see that I've got carbons bonded to each other, and I've actually done something. I've separated the ones with the double and the triple bonds from each other. So what I'm actually going to do is later on, I'm going to show you a video clip of how to find out if there are any double or triple bonds taking place inside my molecule. I've got single bonds here, and this selects me a suffix of ane. So that's A-N-E. This means that I have an alkane. Double bonds over here, I select ene. Triple bonds, I select ine. Something worth noting, and the way to remember these, and I'm always going to give you these tips to try help you remember, is that these guys are alphabetical. So, ane talks about the letter A, then E, then Y. If I go A, E, Y, it's quite easy to remember which order these guys are in, because A, E, Y is alphabetical, 1 bond, 2 bond, and 3 bond. Very, very easy to understand this. What I'm going to do is I'm actually going to start naming these. I don't know what else is bonded at the end of these bonds, but I want to get you into the process. So let's actually talk about how I'd start to name things like this. I'm not sure what is taking place at the end of these bonds, like I said, but what I'm going to do is I'm going to put just hydrogens on the end, and I'm going to pretend like they're there and start my naming process. This should get you ready for later on in the show, where we're going to do lots of practice together. I'm going to ask you questions. I want some Facebook questions, and then we're going to try and see if we can name molecules together. Some of you might be wondering how to draw molecules, and one of the questions that answers is that carbon must have 4 bonds. Hydrogen must have 1 bond, and we're going to deal with oxygen and the halogens and all that stuff a little bit later, so don't worry about it. So I can see that my carbons have got 4 bonds. I've got single bonds in between here, double bonds between here, and triple bonds between here. A, E, and Y. So if we were to name these as if they had a hydrogen on each one of these, in other words, these were all just hydrocarbons, and the naming would stop there, quite easy. Count your longest carbon chain. 1, 2 carbons. And I can actually circle this. I encourage people to actually go through these and circle your longest carbon chain. Now I can see my longest carbon chain. It's there, and it's there, and it's there. All of these have got 2 carbons. Now if you remember from earlier, I select a suffix and a prefix based on the number of carbons, then the bonds. Number of carbons is 2. That tells me eth. Well, if I've got a single bond, that would mean ethane. 2 carbons bonded by a double bond, ethene. 2 carbons bonded by a triple bond would be ethine. I hope that you can see how this works. We're going to practice this a couple of times. If you're not getting it at the moment, that's fine. We're going to have plenty of time to practice. And even when we do our challenge question, I'm going to guide you all the way through it. And we're going to see how that works. I hope that the learners are watching and they're interacting. Are we starting to get some answers coming through?
We've got lots and lots of answers coming through, and I think we've got a few correct ones. We'll see though, guys. Hang on to your seats. It's coming now.
Absolutely. Okay. I'm so glad to see that people are trying this at home. What I want to try to do is I want to encourage learners to take a little bit of a hint here. I want them to redraw the challenge question. I want them to draw it in a way which is much more familiar to them. And this is something that a lot of people really find useful. If you don't know how to work with organic chemistry, get out a pen and start drawing. Practice your 4 bonds per carbon. Organic chemistry is a lot of fun. I love drawing. I'm sure you've noticed my drawing is not the prettiest thing in the world, but once you draw organic chemistry, it actually becomes way, way, way easier than the chemistry which I've actually learned in grade 10 and 11. Okay. I've selected a prefix, I've selected a suffix. Where to from here? Well, I start to take a look at other bits and pieces. There's functional groups. Now functional groups, these are things which actually start adding on to my name. Extra bits and pieces. These are types of things which change the name. Now these ones which I've selected, the first types of functional groups, these are ones which change the beginning of the name. In other words, go on the front of the name. Now, what I've done is I've represented these functional groups. Anything which can replace hydrogen is a functional group. It tells me which family of compounds my organic molecules belong to. Now, over here, where I've got any carbon chain which is coming off the side, in other words, I've got CH3. Let me just highlight as that goes. Now, R can be CH3. It can be C2H5. You might recognize that. So 1 carbon and 2 carbon, you should be starting to think of your prefixes. That's going to come in handy. Now those are in place of R. Now that's not going to make a lot of sense until I actually show you some examples. So in other words, what I'm saying is instead of a hydrogen, I've got CH3. Or instead of a hydrogen, I've got C2H5. That's in the challenge question. I'm hoping that people are actually starting to see this. This is starting to come in the challenge question, and I'm actually answering it for you. Now, other things which change the front of the word, in other words, go at the beginning of my molecule, are any halogens. Halogens like fluorine, chlorine, bromine, and iodine. Sometimes I represent these with X. Now, X can be any one of these. So I can have fluorine on my compound. I can have chlorine on my compound in place of that yellow letter over there. Bromine, iodine, you can even have an astatine, but that's very, very uncommon because it's not an element which I commonly run into. So fluorine, chlorine, bromine, and iodine are very often found on organic molecules. I can make very useful things when I use halogens on alkanes, when I use halogens on alkenes, or even if I start making branches on the side. Now, often people will ask me, what does that make this molecule? What happens if I've got a chain off the side? Well, I'm actually going to write these in just to help you out, because sometimes your textbooks will give you words which you don't recognize. These guys, when there's an actual extra carbon chain off to the side, I call these alkyl chains. So these are alkyl groups. So alkyl chains are extra carbon chains which come off the side. The very nice thing is that that actually tells me how to name them. Alright, alk is usually a reference to the actual carbon chain. Yl is the way that they end. Well, these guys right at the end here, I think I'm going to actually have to crouch down or actually scroll all the way down here to name these. Let's try to see if I can't bring these into focus for you. Fluorine, bromine, and chlorine and iodine, these all exist inside here. I'm looking in element group number 7 or 17. These guys are the halogens. So these are haloalkanes or haloalkenes. These are halo compounds. Now, halo is a reference to salt, but in these cases it's not actually making a salt. The word halogen means a salt maker, a generator of salt. So haloalkanes or haloalkenes, depending on what it's actually joined onto, that's quite important. But now, a lot of this stuff is just theory, and a lot of people are actually saying, well, how am I going to possibly remember all of this stuff? I don't expect you to. So if you're there furiously taking notes and you're saying, I'm never going to remember this, the way to remember this is to practice, start drawing with me, work through the examples, and see if you can find out what we're doing. Well, I'm going to run you through a naming example. I'm going to try to see if you get the hang of it, see if there's anything that you don't understand. Remember, keep those questions for the third part of the show. I'm going to put up something. Perhaps we should take an ad break fairly soon and let learners try and practice this on their own. Let's just put up that question and see if they can get this while the ad break is busy going. Actually, let me hide that away from you. I'm going to work your way through this. I've got an example here of a compound which looks very complicated. I've got 5 carbons in a straight line here, and I've got 1 off to the side. What I'm actually going to do is I'm going to hide away that full name, and we're going to come back and try to see if you can't figure out what it is. 5 carbons in that long chain, copy it down, and there's 1 carbon right down the middle. I'm hoping that you can see that. I'm just going to move that up for you. There's another example, but we'll get to that later. So this first one, I want you to try it for yourself. Let's see if we can name that. We're going to take an ad break. What do you think, Anne?
Yeah, what we're going to do, guys, we're going to take a little ad break. I just wanted to share something with you because Shifa said on the page she thinks the answer is B, but she hasn't done this work yet, so we can't kill her if it's wrong. So I just said to her, don't worry, Shifa, we are not going to kill you. So guys, I think, like I always say, and I probably sound like a stuck record, there is no such thing as a silly question. The only thing, I think it was Mark that said it last week, the only silly thing is when you don't ask the question and after the exam, then you wonder. So guys, get those questions in, keep those answers coming, and I think Phil's going to go off over the challenge later, and I think it's going to be very exciting. See you now after the break. Hi guys, and welcome back. I told you it was going to be a short break, didn't I? So if you are getting tea, come back guys. The show started already. Guys, don't forget to keep those answers coming. Chat to us on facebook.com/learnextra, also at learnextra. Just want to give a quick shout out to our guys at Liberty. You guys rock for making this possible. And Phil, I think what we're going to do is we're going to get straight back to you.
Okay, thank you very much, Indy. Okay,
Pleasure.
Those of you that were working on our little practice question before we went to the break, if you got 3-methyl pentane, you are absolutely right. Now, there's quite a few pieces to this name. I've got at least 4 little bits of pieces of names. Now, I'm going to show you exactly how I got here. I'm going to go through the 3 steps and I'm going to show you exactly where this came from. So if you're new to organic chemistry, I hope that you're sitting there with your list of prefixes and your list of suffixes, and we're going to try and name this together. Okay, first of all, let's go to our naming. If I try to look at this whole thing, well, I'm getting very confused. There's carbons, there's hydrogens everywhere. I have to rely on my rules. Okay. I actually want you to sit there with a pencil, and this is a great skill. And this is a great tip for naming all of these molecules. I'm actually going to go and draw the longest carbon chain. Well, all that requires is for you to count. Now, I want to show you a little thing that a lot of you, and I can see this by some of your answers on the Facebook page, you're not doing, is you're not counting around corners. Okay, so that's a little bit of a hint about our challenge question. I hope you're working hard. There's a lot of discussion going on, a lot of people saying it's definitely one option or the other option. I'm going to show you where a lot of you are actually going wrong. I had a brief discussion with India, and I'm going to guide you a little bit. Okay, so 3-methylpentane, where does this name come from? Well, I don't even want you to look at that for the moment. I'm just going to move that out of the way and I'm going to show you how to construct it with me. Even if you knew how to get there, I want you to make sure that you're going over these steps correctly, you're going through it with me, and we're going to learn together. So, if I've got my carbon over there. So carbon 1, 2, 3, 4, 5. Okay, well, I've got 5 carbons in a row. The question is, there are other options. If I start to count from one side, I can say carbon number 1, 2, 3, 4. I can go around this corner. That's one option. So I'm actually going to start drawing various possibilities. So my one possibility is that I've got a carbon chain which is there, which is 5 carbons long. Quite easy. All I had to do was count to 5. But I've got other options. Let's do those in other colors and we're going to try to see which one is going to be the longest. As I said, I can start there. I can count around. And there we go. I've got a corner there. I can count straight around that corner. What about the other side? If I start from the other side. This is going to start looking a little bit messy, but I'm going to clean it up in a moment. Well, if I start counting from the right hand side and I count right around the corner, I've also got 1, 2, 3, 4 carbons inside the green bit. Okay, but if you do those any way that you count this, I've got, well, 4 carbons or 5 carbons, and I can see that 5 carbons is definitely the longest continuous carbon chain. Okay, well, yellow is the winner. I've got 5 longest carbon chains, and that gives us the prefix. So step 1 is complete. I select my prefix based on the longest carbon chain. That is pent. Remember that pentagon was to do with 5. Okay, so let's get rid of those other backbones. I've got my longest carbon chain, which is now circled. That is 5 carbons here. And I've selected a prefix. So I'm actually going to color code this as I go along. So the yellow part represents my backbone, sometimes it's called, because this is the thing on which my organic molecule is actually built. It's all about the carbon. So I've got pent. All right, there we are. Now the question is, how are these carbons actually linked together? Well, if I take a look at my reaction here, well, it's not actually a reaction, it's a molecule here. If I take a look at the bonds between carbon here, these ones that I'm highlighting at the moment, if I do that, I can see that these are all single bonds. Now if you remember, single, double, triple, A-E-Y, so this is pent, and I'm going to complete the name with a suffix. This is pentane. So pentane tells me that there are 5 carbons, and ane tells me that they are single bonded to each other. So that was actually quite easy. All that I figured out is that now I have 5 carbons. That told me where I got pent from. Single bonds told me about ane. So I'm actually going to write these. If you're new to this, I want you to be taking notes. I want you to be finding out where I get the bits and pieces of my names from. So just re-emphasizing where these pieces came from. The pent, that part was from the 5 carbons which came out here. Where did the ane come from? Well, ane was talking about the bonds in between them. So let's put that back together. I've got pentane, meaning 5 carbons. I've got 5 over here. That means that I've got 5 carbons, and ane means that I've got carbon, single bonded carbon. You don't have to do this, but this is just for those of you that are learning and revising, which should be all of you. Okay, now most of you have spotted that there's a little something extra. There's a carbon which has been left out in the cold. It's something off to the side. It doesn't participate in any of the backbone naming. Okay, well the question is, how do I name this extra little piece? I've got 1 carbon off to the side. Here's your answer. I name it as if I was going to name a normal carbon chain. I select the same prefix. So 1 carbon, remember MEPB, 1 carbon gets me meth. But now to show that it's off to the side of a main carbon chain, I call it methyl. Yl is an indication that it's a side chain. So when I put it on here, I'm going to call it methylpentane. So I'm actually going to circle it in green so you know where the part of the name comes from. So I've got a part of the molecule here. That is a methyl group. Okay, well, let's write it in here. Now before you write it in here, I want you to show that there is no spacing between methyl and pentane. It's all one word. Here's the golden rule for organic naming. If there's no breaks in the carbon chain, which there isn't, I can see carbon all stuck to carbon. I think I've moved my molecule around there. It's getting very excited. Okay, if I've got carbon bonded to carbon, I've definitely got no space For any carbons to break to any other atoms, that means that if there's no breaks in carbon, there's no breaks in the word. I want you to remember this. This methyl is right up against the pentane. It's one word. Now, if you remember, there was a number involved here. My name was 3-methylpentane. Where on earth did this 3 come from? Well, it's actually quite easy. It's the same as if you're writing a letter to somebody and you just wrote their name on the front and you put it inside the post box. There is no chance that it would find its way to the right person. I must put a living address on that postal address. Now, that means that I've got to give it an actual street number or where it lives. Well, the methyl's got a home on my pentane. Well, there's my methyl. The problem is that the methyl can move anywhere along my pentane. So if I've got methyl, it's got to have a place on my carbon chain. So in other words, my pentane. Well, where does it live? I start to count. Well, my pentane's got 5 carbons to choose from to put it on. I've got to find out which carbon the methyl is on. So I start to count from the left and from the right. I'm going to show you why in a moment. So I'm going to number my carbons. I'm going to give them street addresses. I'm going to make these places to live for my methyl. So if I start numbering 1, 2, 3, 4, 5, I've all of a sudden got a living address for my methyl on the side here. This tells me that my methyl group or my methyl group, depending on how you say it, is living on carbon number 3. The really lucky thing for us is that we can start numbering from this side and it'll still be on carbon number 3. So in other words, if I say carbon number 1, 2, 3, it's still on carbon number 3. The rule is you've got to choose the system of numbering which gets you the lowest number. And I'm going to show you what happens when we start moving around the methyl. Okay, so I know that the methyl group is living on carbon number 3. So there it is, carbon number 3. Let's give its living address, and I'm actually going to move that 3 into its place there. I know that this 3, oh, I'm actually dragging the 2, let's write a new one. 3-methylpentane. Let's go through the pieces that I'm talking about here. Well, this methyl was a part on the side. This was all new. I'm going to start from the beginning. Pent, meaning 5 carbons. Ane, indicating that I've got a C, single bond C, so there's only one bond between the two of them. Methyl was talking about the little extra CH3 sticking off the bottom of the pentane. It wasn't part of the carbon chain. That I cannot emphasize enough. Where did the methyl live? It lived on carbon number 3. Let's go through one more example, and I want to see if you can figure out how I got the pieces of the name. I've written down the name here for you, but I'm going to run you through those steps again. I'm going to highlight with you, we're going to see what happens, we're going to try to see if we can't name it, and I want to show you something very interesting. Alright, we're going to try to see if we can't make a little bit more space here for you, because there's a lot of information. Let's actually see if we can't clean it up and make sure that you can see exactly what's going on there. There we go. Alright, so we've got 3-ethylpentane. How do I go about naming this guy? Well, let's start from the beginning. Longest carbon chain first, then we're going to see what else is inside there. Now I'm going to do something which almost none of you, I can bet, have done at home. So I'm going to highlight my carbon chain, and I'm going to do it in a way that you're not used to. I'm going to count around the corners, and I'm going to show you that the longest carbon chain can actually be around a corner. So I'm going to count here. 1, 2, 3, 4, 5. And the name is going to come out exactly the same. As long as I followed the rules, I should be fine. So my longest carbon chain here was definitely 5 carbons, and once again that gives me pent. So there it is. That's where that part of that name came from. Where does the ane come from? Well, I've got single bond, single bond, single bond, single bond. That means that I've got ane over there. So let's just make sure that we understand where these pieces of these names are coming from. So my single bonds all the way through are actually telling me where I've got my bonds. So those are all single bonds. So that's where my ane is coming from. Right, that's not too difficult to understand. The question is, where did this little extra piece come from? Where did I get ethyl from? Well, take a look and see what's not part of the carbon chain. I can see my carbon chain, my longest carbon chain, or my backbone doesn't include this guy. Well, let's include him. Let's actually circle him in a separate color, and let's see why it's not included. Well, I've got my 5, I've got my 2 carbons, off in a chain over here, which is C2H5. Sometimes it's actually written like that, and you might find that this is actually written this way as a shorter way of doing things. So this is an ethyl group. I hope that you can see that 1, 2 carbons gets me the prefix eth, and because it's an alkyl group, in other words, a side chain, I name it ethyl. And that's where that part of that name is coming from. So I'm color coding this the whole way through. The last thing to do is find out where the ethyl lives. Well, let's do our numbering. Let's do the numbering together, and let's see if we can't figure out why it's 3 ethyl pentane and not, for instance, 2 ethyl pentane or 4 ethyl pentane. Remember, I've got to choose the lowest numbering scheme possible. Well, if I start numbering from this side, it's 1, 2, 3. So that's where my ethyl is. 4, 5. Just to drive a point home, I'm actually going to number from the other side and see how we go from there. So 1, 2, 3, 4, and 5. I can definitely see it doesn't matter which way I number it, I'm going to have the ethyl on the 3rd carbon. Okay, I'm hoping that people are getting the alkyl chains. I'm just going to finish off with a little bit of halogens, and we'll try to see if we can't work in a little bit of oxygen. I'm not sure if we're going to have time. I want to get through to some of those questions and answer that challenge.
Cool.
All right, so now you can actually guess how these names come about. I just want to drive a point home because a lot of people are not sure where these names all come from. Well, it's actually really, really easy. Same steps. Prefix, suffix, functional group. So let's run through these steps with these examples. I want you to try and name them as I go. I'm going to do one with fluorine, chlorine, and bromine. So all of these all together. I'm going to highlight the pieces of them which are important to each other. Let's see how I can actually do this. Well, 1 carbon, there it is. That's going to get me my prefix. There it is. Meth. Meth stands for 1 carbon. Well, the only way that you can join 1 carbon to other carbons, and it doesn't in this case, is with single bonds. So I've definitely identified that I must have methane. I wonder if you can figure out why I don't have methene or methine. Those are actually impossible compounds. Where does fluoro come from? Just make sure that you spell fluoro correctly. It's not fluoro, as a lot of learners are actually spelling it. Where does fluoro come from? Well, it's fluorine. All you do is you take the front part of that element's name and put an O on the end. And this is how I name functional groups containing halogens. So if I've got an F in place of a hydrogen over there, I find that I name it fluoro, and there it is. I hope that you can see that. Fluorine, fluoro, and if it's on 1 carbon, it's methane. Well, it's quite easy. I'm going to quickly run through these others and see if there's any questions after this. And I think we almost due for a break, but we'll see how it goes. Again,
so well.
Good. I hope that the viewers have managed to.
Have we even taken one break?
Only 1 break. We're on a roll. I love organic chemistry, and you can obviously see it. So chlorine, chloro. There it is. I've taken the front part of chlorine and I've made it into chloro. Now, if I move that down, it's very easy to predict where this is going. If I've got bromine, I go bromo. Now, it's very, very easy to do these ones. These are actually the easiest of them. If there's a halogen in place of a hydrogen, all you have to do, and let's make sure that that's complete, all I have to do is make sure that I take the front part of the halogen, so in other words, bromine becomes bromo, fluorine, fluoro, chlorine, chloro, iodine, I haven't shown it here, but it is iodo. Okay, quite a weird one, but there it is. Okay, I think we've probably got some questions, and I'm not sure how we're doing for time, but it might be time for a break.
Yes, guys, I think what we're going to do is we're going to give Phil a little bit of a break, because he's been talking a lot. That gives me a chance to get a little bit of talking in during the break, because you guys know how much I love talking. So what we're going to do, take a break. As soon as we get back, we're going to be going over our challenge question, and I know that you're all dying to know the answer. So we'll see you then, after the break. Hi guys, and welcome back to the last 15 minutes of Learn Extra Live's Physics Grade 12. I just want to give a big shout out to Liberty. Thanks guys for making this all possible. You guys rock. I know we've only got 15 minutes left, but now finally the time is arrived for the challenge question. I know there's a little bit of healthy competition going on there. It's all very exciting. So finally, I know Kashifa says that her and her brother have come up with the answer, and they're pretty sure that it's B, and they hope they're right, even though they're doubting themselves. And I'm sure you're all shouting out your answers while you're sitting on the couch right now. I know, guys, I've seen all of your answers. You know what, Phil, let's get straight to it.
Okay, thank you so much, Indy. Okay, well, I know that we're getting a lot of your questions in. What I'm going to try to do is answer as many of you as possible. I've got a particular example which I think is going to answer at least 15 of your questions at home. So please be patient. Okay, I wanted to run through a couple of these things. There's something on this molecule which we haven't done in this lesson yet. We haven't had time. But using the skills that we've learned so far, I hope that you've been paying attention. There's a trick to this question. One of the things that a lot of people get caught on is counting the longest carbon chain. Well, I see a longest carbon chain here of 1, 2, 3, but don't forget there's a trick. I need to count around the corner. Let me actually highlight that carbon chain like I told you to do earlier. If I take this carbon and I start highlighting all the way around it, ooh, all of a sudden I have 4 carbons in my longest chain. Well, that allows me to simplify things really greatly. All of a sudden this means that my longest carbon chain is 4. If you select a prefix of bute, remember MEPB, that means that I've got bute as my prefix. I can start taking a look through here and wiping out a couple of opportunities. Well, prop, do you think that's right for 4? Absolutely not. Option A is cancelled. Option A is not correct. If I take a look at option C, I see propanoic acid. That's something quite new, but I know that prop is not right. So option C is definitely out. What about option E? Let's take a look there. I see the word prop again. That prefix is in there. The only problem left is to decide between B and D. Now, this is a little bit of work which, if you haven't covered this, this is going to be quite difficult. However, I can teach you a little bit something before we actually start this. Oxygens. Oxygens are hugely important inside organic chemistry. In fact, they're almost impossible to ignore when we start taking a look at numbering. When there's an oxygen, especially at the end, like there is one here, that's where our numbering starts. And that's the key to today's challenge question. So if I start numbering from the side closest to the oxygen, in other words, that becomes oxygen number 1. Even if you didn't know what this is, which some of you don't, and that's fine. If I start numbering from that side, and let's number in green. If I make that carbon number 1, that carbon number 2, that carbon number 3, and that carbon number 4, I can see where the chlorine is. Remember that chlorine becomes chloro. So on the 3rd carbon, I have chloro. I have a prefix of bute. And this thing at the end, as most of you have started guessing, must change the end of the word into oic acid. And that's one of the things that we didn't really have time to cover today. But I can see that option B is the correct one. I can see that on my 3rd carbon, I've got a chlorine, and that makes it chloro. I can see over here bute, which means 4 carbons, and oic acid, and that's talking about that part. Just for reference sake, if you haven't learned this, a good thing to remember, if you see this pattern at the end of a chain, that changes the end of the chain into oic acid. Now, even if you hadn't done that section before and you just listened to us tonight, you could actually follow the clues and figure out, well, if I count around corners, I've got 4 carbons as my longest carbon chain. So option B is the winner for tonight. The reason that option D is incorrect is because that assumes that we start numbering from this side, and that's wrong. I start numbering from the side which is closest to the oxygens or the double bonds. So if I have double bonds or oxygens, they take priority and they decide where carbon number 1 is. So there's carbon number 1, carbon number 2, carbon number 3, and that's where there's a chlorine, and there it is. 3-chloro. I'm actually going to underline it. 3-chloro. There it was. Bute for the 4 carbons, and because they're single bond. So there's lots of clues to show you that B is the correct answer. If you got that, congrats. If you didn't, you learned something. There is no such thing as a wrong answer. Some more questions, Indy?
We do have a few more. Let me have a look. Shame. I've got to read this out now. Kashifa said, thanks, Indy. Wow, I never thought I would be right. I'm ecstatic right now, jumping around. Her mother thinks she's crazy. Thanks, Phil, and thanks, Indiana. So well done. And I see her brother Mohammed also posted on the wall. So hello, Mohammed. I think he must be about 9 or 10. But I think that's great, guys. Guys, if you didn't get it right, it's okay. Like Phil said, there's no such thing as a wrong answer. Really, really. Noxypedia and Jack also had a nice little bet going. She said it was going to be B, and he said it was A, and she got it right, so well done to her too. Let me have a look here. What else do we have? Let's see.
I think there was a question about double bonds a little bit earlier that you read to me during the break.
I know, but you know what happens, Phil, is that there's so many comments that they actually go to the bottom of the page. So guys, you're making me sweat here. You're making me sweat. I am going to find a question any second now. I know. Hold on. Sorry, Phil.
No problem at all. I've actually got one of those questions that you remembered from earlier.
So you mean you remembered one of my questions from earlier?
Absolutely. Okay. So
yes, thank you, Phil, for saving me.
Okay, what I'm actually going to do is I'm going to design a question that's actually going to help at least 3 of your concerns. Some of you were worried about what happens if there is a double bond in multiple places. What happens if there's also a branch? So you're going to practice with me. Everybody at home should be doing this with me. I'm going to draw a carbon chain with a branch, with a double bond. We're going to name it together, and you're going to tell me what its name is. Well, let's take a look at an example. Let's actually make some space here. Let's get all the confusing stuff off. Challenge question is over. Let's start fresh. So I've got 1, 2, 3, and 4 carbons, except I'm going to throw in something a little bit extra into that last little bond space. I'm going to throw in a double bond. Now, to make things very, very special, what I'm going to do is I'm going to put on a branch as well. So there's definitely 2 things about this molecule which are really weird, really interesting. Don't forget to fill in your hydrogens. Each carbon needs 4 bonds. So there we are. We've got 4 bonds on each one of these carbons. Make sure that you put in your hydrogens. I'm pretty sure that you guys are going to get sick of drawing hydrogens once you've done with organic chemistry. But I love this stuff. I've been studying it for a long, long time, and I'm still not sick of it. Organic chemistry is lots of fun. It's just drawing pictures. Okay, so I've got my organic molecule here. Let's go through the steps together. Step 1, 2, 3. Prefix, suffix, functional groups. Okay, well, I see some really interesting stuff here. Really, really familiar if you're watching us before the break. Let's find our longest carbon chain. This is going to get very predictable. I find 1, 2, 3, 4. Or, what happens if I count around the other way? And I'll go, 1, 2, 3, 4. Now, one thing I do want to impress upon you, and this is something which I haven't shown you yet. If there is a double bond, it's important. It must be part of your longest carbon chain. It's so important that it's actually going to decide other parts of your naming. I can't, for instance, go around there. Even though that's shorter and that's 3 and I wouldn't do it, the 4 carbons must include your double or triple bond, if there are some. So either way, green or yellow, doesn't actually matter. Somebody said, well, what happens if I have both options? Both options are correct. What happens if I decide, no, well, I'm going to throw away the green. Let's use the yellow. Let's use that as a backbone. That's absolutely fine, and we're going to come up with the same name. That's the beauty of the system. If I follow my rules, I'm going to come out with a name, I'm going to get my marks. Fantastic. So, if I go 1, 2, 3, 4, M-E-P, B. B for bute. So, I've got bute. The question is, how is it named? Well, bute, all of a sudden I've got something new. I have a double bond. I'm actually going to highlight this thing. I'm going to show you that there is something new happening inside here. And I actually want to draw a nice little square around there. There's a double bond. Remember, ein, een, ein. Which one is this? Well, single bond is ein, double bond is een, triple bond is ein. So this is an een. Well, I'm going to write it there for the moment. I'm going to put it into my name in a moment. I know that the een is somewhere inside my molecule. There's something else on my molecule which doesn't quite fit in, and I actually like to write it onto my molecule. Well, let's circle what that is. I have a 1 carbon chain which didn't actually fit into the whole thing. There it is. I've got the odd one out. I've got the side chain. I've got the thing which did not form part of the bute. That is methyl. Well, the problem is that I've got methyl on one part, I've got a double bond somewhere else. Question is, how do I number this thing? Very, very, very confusing. Well, here's the rules. If I have a double bond, that's where I start numbering from. The side closest to the double bond or the triple bond is more important. I can see that my double bond is over here. It's on carbon number 1. That's where I start to number from. If I didn't have that, I would start numbering from the other side, because that's closest to the other thing which makes this molecule special, which is methyl. So let's do that. Let's number. I've got 1, 2, 3, 4 carbons, and there they are. I've numbered them. I've made them into carbons where things can live. Well, I know that the ene lives on the first carbon. So what I'm actually going to do is I'm going to give the ene a living address. So when I put my ene into the name here, this is butene, I need to put in a living address. Something which you'll notice which I do is I separate the words from the numbers with a dash. So I'm telling you that this is going to be but1ene. That means that I've got but, 4 carbons, and on the first one I find a double bond. So that's actually telling me where things live. What about the methyl? If I take a look at the methyl on the side, or the methyl, I actually find that it's on the 3rd carbon chain. Well, let's move into the methyl. Let's move it into the right place. I can see that this is methyl but1ene. Let's put a number on the front. Let's actually move everything off to the side. Let's make this a little bit cleaner. Let's see that everyone can see where we're going with this. Well, I'm going to move this whole thing down and give it a little bit of an address. If I've got something methyl but1ene, I've got to say where the methyl lives. Well, look at your diagram. Your methyl lives on the 1, 2, 3rd carbon. This is where the methyl or the methyl lives. And I'm going to write that in. Remember to separate your words from your numbers with a dash. So I'm going to say 3-methyl but1ene. I hope that answers some of those questions at home, and I'm sure that there's tons rolling in.
They did. There's lots. There's actually, I think most of the mindsetters actually got that question right. So you obviously have taught them something very valuable today.
Fantastic. I think we've got time for a very, very short question.
For a very, very short one. Okay, let's have a look. Oh, Mohammed asked, what happens if there's a single, a double, and a triple bond?
Ooh, very good question.
Long question.
Okay, a single, double, and a triple bond. Well, I've got to actually name them. I'm actually going to give you a very, very brief example. Okay, well, the double will get you an ene. The triple will get you an ine. The double is more important than the... Well, it's actually alphabetical, the reason behind this. I'm going to show you exactly what's going on there. What happens if I've got a double bond on one side and I've got a triple bond on the other side? I'm quickly going to put in the hydrogens. I want you guys to name this for me. Put in the hydrogens which I need. Well, I've got 1, 2, 3, 4. We've seen that that is but. Well, that shouldn't be new to you. There's 4 carbons in longest chain. Question is, I've got a double bond, I've got a triple bond. I've got to figure out which one to do first. So there's a bit of a trick to this one. This is something which extends beyond what we had time for today. I've got a double bond there which gives me an ene, and there's a triple bond here which gets me an ine. I'm not sure how much time we got there. Do you know, Indy?
How much time do I produce? Just give me a chat in my ear.
Okay.
About 1.5 minutes. You can do it.
Okay, fantastic. Well,
that means you get 1 minute and I get 30 seconds, so go.
Okay, great. Okay, no pressure at all. What we're going to be doing is numbering these carbons. The question is, which one of these takes preference? Well, if it's the same from both sides, do you see that I can number it 1, 2, 3, 4, or 1, 2, 3, 4? If it's the same both ways, I choose alphabetically which one is more important. Ene comes before ine. You'll actually find that your double bond takes preference over your triple bond, and that will take numbering preference. That means that this guy is going to choose where the numbers come from. So there is carbon number 1, 2, 3, 4. Let's move them into place. So ene before ine, because it's alphabetical. I've got to make one more adjustment though. I've got to make sure that my E doesn't stay inside there. You've got to put in your numbers, so it'll be but 1 ene, 3 ine. I hope that answers the questions at home. I think that's all we've got time for though, Indy.
Yes, guys, unfortunately we have come to the end of the show. Don't be too sad. Mamelo said she learnt a lot, especially from the mistakes she's made. And Bali said, thanks guys. The lights are turning on for me, so yay me. Guys, grade 12s, thank you so much for joining in to learn extra live physics today. We've had such a great time. Thank you so much, Liberty, for making this all happen. You guys rock once again. And guys, hope you tune in next week to learn more and learn extra. See you next week, guys. Bye.
Bye.